man, what a great day at school. Learning physics from my favorite physics teacher, Mr. Parala. But boy, am I hungry. Wonder what I have. Let's see what we got. Oh, my favorite! Oh boy, a canned lesson. Let's open her up.
An object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by a push or pull outside of the object's original motion.
Force equals mass times acceleration.
For every action, there's an equal and opposite reaction.
These three seemingly simple laws are the foundation for the house that is physics, and today we'll be digging deeper into just what they mean.
We will conduct 3 experiments, one for each law, and explain what's happening and why for each experiment.
Let's get to it!
Great! Sir Isaac Newton said it best. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force.
Let's show you using this box.
Go.
Newton's first law is essentially telling us that an object that is sitting there will continue to sit there unless it is moved. And an object that is moving will keep moving unless it is stopped by something else.
Some more examples of this include how a soccer ball sitting on a field won't move unless someone kicks it. Or when a soccer ball gets kicked into the net, how it will eventually come to rest.
This is because when a ball is kicked, the foot kicking is exerting a force or a push. The soccer ball therefore pushes back on the foot. But since the force the ball exerts on the foot is smaller than the force the foot exerts on the ball, an unbalanced force, the ball is moved.
Along with this, once the ball hits the net, the ball pushes on the net and the net pushes back. Since the net is larger, heavier, and stationary, it presents a larger push on the ball than the ball presents on the net, therefore bringing the ball to a stop.
Newton's first law can be basically summed up in one word: inertia. The definition of inertia is a property of matter by which it continues in its existing state of the rest or uniform motion in a straight line, unless the state is changed by an external force.
Great! In other words, inertia is what keeps an object either at rest or in motion. In our first lab, we will be demonstrating this property.
This quarter has inertia, which means that it wants to stay exactly where it is, and it will, as long as no force is strong enough to move it, act upon it.
The force of static friction between the quarter and the card is strong enough to move the quarter along with the card, just so long as the card is moved slowly. However, when the card is moved very quickly, the friction is changed from static to kinetic, which has a significantly smaller coefficient.
The force of friction is no longer large enough to overcome the inertia of the quarter. Therefore, the object at rest stays at rest.
Physics! Force equals mass times acceleration. This is Newton's second law of motion. To break it down, this law is essentially stating that if 2 objects have the same acceleration, the heavier object will have more force. On a similar note, if 2 objects have the same mass, the object with the greater acceleration will have more force.
To demonstrate this principle, we are performing this with a toy car. Vroom, vroom.
Go.
Did you get what she was at? Did you get what distance? Go. Well, dang, she went further.
As you can see, the car with the greater mass went further, just as expected. The car with the greater mass, with the same constant acceleration of gravity, had a greater force, producing a longer distance. Physics. For every action, there's an equal and opposite reaction. For example, if I punch Nick, he'll probably say something like, ouch, and move away from me.
That's not exactly what he meant. Newton meant that if I put a force on an object, that object will push back with the same force. So like if I push down on this table, the table will push up at the same force that I push down.
Nick pushes down on the table, and the table pushes up on Nick. Nick exerts a force, and the table produces an equal and opposite reaction. However, since Nick isn't exerting enough force to break the table or push it onto the ground, it stays where it is. But that doesn't mean that it isn't reacting.
Okay. To put this law to the test, we will be using a special rocket car to demonstrate how an object can move by means of action and reaction. We've taped a straw to our car and attached a balloon to the end.
According to Newton's third law, when we let go of the balloon will push on the air. Since the balloon will push on the air will then push back on the balloon. And since the balloon is attached to the car will be pulled along by the balloon when the car pushes on it. Let's see. Physics!
That's physics. Today we learned about Newton's 3 laws of motion, the physics behind them, and even some proof for each one.
The quarter, cup, and card taught us that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force.
The car and the ramp proved to us that force equals mass times acceleration.
And the rocket car showed us that for every action, there is an equal and opposite reaction.
By golly, Sir Isaac Newton was right. But I guess he doesn't need the validation of 2 high school students anyways. Ka-chow!